Good evening, everyone. This is Freddie Ziegler from the National Water Service Office here in Cleveland. I'm just doing a sound check just to make sure everybody can hear my voice. And if you can place that in the chat or the question section saying yes, confirmation, that will be great. And also, if you can see the screen, the front page of the 2022 Skywarn spotter training. If you can see it, say yes. Thank you. We have about 5:54. We're going to start probably right at 6 o'clock because I have over 100 slides. If you actually viewed this last year, some of it's similar, but some of it's a little bit different. We added a couple of more slides from the October 21st event, and also because we're kind of full-fledged in person. There were a few counties that were unable to, we were unable to secure a location. So we're going to be concentrating on a couple of counties in Northeast Ohio, Trumbull, Mahoning, and Portage. And I know there's quite a bit of residents that are actually on from those areas, but there's lots of information that everyone can use, but definitely going to have some tornado history from those three counties. But we'll start in about 5 minutes. I have 5:55. We'll start at the top of the hour. I have 6 o'clock or 5:59, getting ready to get to the top of the hour. I appreciate you guys getting on. I think we have over 100 people on, at least for the online course here. You know, this year we wanted to do something special, and I believe, you know, we tried to get the timing right. But I think going through this pandemic and going through COVID, I think we're going to pretty much do in person and online moving forward. So not only this year, but we're going to be doing it for years to come to interact with different people from different parts of the Northern Ohio. And I'm pretty sure there's people outside of Northern Ohio and Northwest Pennsylvania that will be joining us. This spotter training is targeted for Mahoney, Trumbull, and Portage County, but there's a lot of valuable information that can be obtained from this spotter training that can help you regardless of what part of the country you're located in or what part of Northern Ohio or Northwest Pennsylvania. Definitely, we have a full schedule in-person spotter training schedule that's for the remainder of April and also in early May. Hopefully the severe weather and the storms hold off until mid-May, or maybe into late spring and early summer. We can kind of hold off because we do have a full schedule. And, you know, if one of those days are canceled, then it's probably going to be moved back to the fall season. I made a pledge to the emergency managers of all 3 counties that we will try to be in person in the fall to kind of capture not only the severe weather threat, that secondary severe weather threat that occurs in October and November, but also getting geared up for the snow event for some of those snow belt areas as well. So I'm going to hide my face, which I'm happy to do, and so we can kind of get started. Okay, so we're going to get started with the 2022 Skyward Spotter training, the basic course online for April 14th. And it's on a Thursday, kind of right in the middle of April. And I am glad we have a lot of people on right now to join us. The spotter training is basically to actually empower you guys, the spotters out in the field, to help us. We need that teamwork, working together, not only the forecasters issuing warnings, but also having that ground truth in the field to make a warning stronger and credible. We're gonna cover some things as far as training, equipping you guys out in the field, so you can have the knowledge to actually identify types of clouds, types of storms, how to identify and how to actually connect with our office, not only our office, but also the emergency managers in your county, but also making sure the information is correct by giving us the time, giving us the location, and also giving us an estimate of what you're looking at. So we're going to go over some of those things as well. As you know, the National Weather Service, or if you don't know, the National Weather Service actually have about 122 offices across the United States, and also in Guam and Puerto Rico and Alaska and Hawaii. We have 14 forecasters in our current location in Cleveland, or the south central portion of the metro area of Cleveland and Brooklyn Heights. We have 5 electronic technicians and IT personnel, 3 administrative meteorologists, that includes myself. And you guys are familiar with Gary, he's my boss, and also Bob, our science operation officer. 1 operational observation program leader that kind of covers all the co-op observers. They do a diligent job of actually collecting the data as far as snowfall data, rainfall data, and actually he kind of, you know, this individual actually makes sure the data is correct and kind of QC it, if you will, over the data and send it to the National Climatic Data Center, the NCEI, down in Nashville. Our hydrologist that covers the rivers, everything hydro, and also our administrative assistant that makes sure we get paid. We're open 24 hours a day. Yes, we're open on Good Friday and Easter, 24 hours a day, 7 days a week, Christmas, Easter, Mardi Gras. all the holidays. And we are the office that issues the tornado warnings, severe thunderstorm warnings, flash flood warnings, hard freeze warnings, wind advisory, high wind warnings. Yeah, that comes from our office. But I'll actually show you some differences where some of the watches and warnings come from. And they not all come from our office, but a good majority of the products that you're going to be seeing in the field, on your phones, and different types of mediums comes from our office. Locally, kind of regionally, the state of Ohio is covered by 4 offices. Pittsburgh, that covers east central portion of Ohio. Charleston, West Virginia, kind of covers that extreme southeastern portions of Ohio. Wilmington, that's the Cincinnati office. They cover central and kind of southwest Ohio. And North Webster and northern Indiana covers that extreme northwest Ohio areas. And then also Cleveland area in light blue, we cover north central and northeast Ohio. We also have responsibilities in extreme northwest Pennsylvania. Why we need spotters? That's a kind of a, you know, that's been our relationship with the spotters for almost 40, 50 years as we've been doing these sky ones and reaching out to you and training the public out in the field how to become a spotter. Actually, you know, when we're sitting in the office, we're looking at radar. A lot of times we issue the warnings based off of radar. But if we have that ground truth, that really makes the warning very credible. And what we really want is people to take action once they get that warning. You guys are part of that formula, you know, as far as getting that credible warning. And the idea is actually getting people to act once they hear the warning, once they receive the warning on their phone or through TV or they know on the radio or even driving. Yeah, we want action to be taken once the warning is issued, and especially if there's confirmation from the spotter community, that will definitely help. Other reason why we need spotters is because, you know, we don't have radars in every county, every township. It's somewhat impossible to have it there, but we try to have radars that are spaced out, but close enough to give us information across the United States. You know, there's, you know, out in the West, it's a little bit more spaced out. There's beam blockage by mountains, but here, our issue is a lot of times storms that, you know, we're looking at the radar that's on the left-hand side, and we also looking at cloud A, we can say that's a storm, and cloud B is a storm as well. Well, the Earth is round, believe it or not, and it curves. But the radar beam does not curve that much. And what's happening with storm A, we're able to see the bottom portion of that storm and upper parts of the storm. But in storm B, the lowest portion of the storm that we can see is actually in the middle portion, the lowest cut of the beam that's actually looking at storm. So we can only see, you know, just the middle portion of that storm. So a location like possibly like Erie, Pennsylvania, we do have some issues looking at storms. Sometimes snow showers, we have problems there because they're kind of low, you know, about 10,000, maybe 8,000 feet. A lot of times we don't see them. And so our snow spotters actually give us information about that. A lot of weak signatures that are 90 miles away from the radar, sometimes they're kind of difficult to see. Our radar operators, our forecasters here in the office are able to discern what's going on, and they can kind of detect, okay, we know the principles of the radar is weaker the further out we go, and we're looking at a storm, and it could be exhibiting some features that may have some severe weather like hail or a tornado, but we really need some ground truth for some areas that are out there, especially some of those marginal, you know, possibly severe. Now, we're not going to miss those real, you know, baseball-sized hails or EF2s, EF3 type tornadoes, but those real weak tornadoes that are far away from the radar, 70, 80 miles, 100 miles away, sometimes they're going to sneak under the radars, as we can say, and they're very short-lived. They're very difficult for our radar operators to see that because what's happening to radar, actually, you know, the radar beam is a little bit further off the ground, that far out. With dual pole, I'll give you a little short synopsis of what happened as far as radar. Of course, radar, just a little bit of history. Radar was a military type radar that was actually used in World War I for detecting, planes. And lo and behold, they found out that storms were getting in the way, and they weren't able to penetrate some of those storms, and they were actually indicating a lot of weather phenomena. But it was just a beam that went out and a beam that come in. So it was kind of listening mode, did not have the fancy stuff that we have today. Back in the mid 50s, we did get a network radar put into place in the late 50s and early 60s. That kind of stayed into operation as late as the early 90s. Actually, when I came into my career, we were actually operating on the 57 is what they call it, the year it actually went into creation. But the network usually takes about maybe 6 or 7 years, maybe 8 years to get out into the field. By the time I came in, it was still it was phasing out, and we were actually kind of getting the new Doppler radar at the time, the 88D. Fast forward 20 years later, around 2010, we added some more features to the 88D, not only the Doppler effect of listening and then also seeing particles moving away and towards, but we're also able to see particles vertical and horizontal to give us more information about what's going on the radar. We can actually see snowfall. Not only snow, we can see dry snow or wet snow, hail, large hail, small hail, water droplets, large water droplets, small water droplets. We also can see insects, birds, fire. In certain atmospheric conditions, if there's an inversion or warming above the maybe about 6,000 or 7,000 feet, we can see, we can't see individual cars, but definitely we could see, just traffic. And I won't say like individual cars, but we could see the speeds of the cars on traffic if the beam is kind of bent down a little bit. So there's some certain things we definitely can see on the radar with the dual pole that's been out for at least about 10 years. One of the things with the Doppler radar, not only we can see whether there's rainfall occurring or light rain, or big hail and stuff like that, but we also can see what's moving towards and away from the radar. So on the top left, you see the reflectivity. We're looking at, light rain in the green and blues, and then a heavy rain in the reds, pinks, and white. If there's, if we get something that's white, that's a good indication that could be very heavy rain, could be hail, depending on how high it is off the ground. So there's a lot of variables that goes into that. As far as velocity, we can actually see how fast these particles are moving towards the radar or away from the radar. So speeds moving away from the radar is going to show up as red. Speeds that are moving towards the radar are going to show up as green. If we have a real tight to get, that those colors kind of matching close together, well, that may be something, maybe something's going on. Maybe it's something that's converging together, or maybe there's a couplet going on that could be a possible circulation that's there. I didn't say tornado as of yet, because a lot of times we may indicate a nice circulation, but we may not have a tornado on the ground. And sometimes, we issue warnings based off of radar signatures, but having that spotter in the field definitely helps. So this is what's happening. Radar samples thunderstorms, and not waiting for, the thing that we're looking for here is looking at the distance here. This is kind of the example I gave before. You're looking at hails in storm A, a possible tornado there, but then in storm B is farther away, and you can see a situation where the circulation may be below the beam. So the distance does make a difference there. A lot of times, if there's a strong tornado or a violent tornado, that's going to exhibit circulation throughout the storm, and we're not going to miss many of those types of storms. Those weak tornadoes, we do have some difficulty, especially when they're 100 miles away from the radar. We tried to litigate that by having radar coverage from other radars to kind of cover that. So we're not, it's not a situation that we won't see a lot of things. If you notice, from Cleveland to Pittsburgh, that's less than a 2-hour drive, depending on what parts of the metro area. So that's two radars that are actually overlapping, so we can see a good deal of areas like Youngstown and Trumbull and Ashtabula. Those are covered by two radars. So our guys, our forecasters here can actually look at two radars and actually see what's going on from different vantage point. That does help. In a situation, as far as, I talked about Erie as far as snowfall, especially those convective snow bands that occur across the lake, that can occur. That can be a situation where the actual snow is very, the cloud tops are very low. They can be somewhere 6,000, 8,000 feet in certain situations. We cannot see that. And so we've done some things here in the office, as far as the radar, to lower the beam to try to see more of those low top type showers and snow bands that occur at a distance away from the radar. And so you can see the action here, how that action is occurring away from the radar, and how we try to look at things. And then we also have Buffalo to kind of look at some of those things as well. Buffalo radar, we kind of look at it, and we also have Pittsburgh to kind of look at it. So we have three vantage points to kind of help us in that situation, trying to look at different types of snow bands that may occur across Erie and Crawford and Ashtabula. So what's happening to the radar beam as it moves out? So the radar beam is on the left-hand side there, sends out this electron magnetic wave. Initially, it's very close together. The beams kind of move, and as it moves away, the beam fans out. The beam width gets larger. And so what's happening over time, the radar really tries to try to fill in some things, and we're aware of that as far as the radar operator. And so the storm to the left-hand side, you can see it's more detailed and more refined. You can see the details of it. You can see, this is kind of like the old hook echo, but that the storm to the right is not as detailed. And so that's what's happening with the radar. And so it takes, take these guys here at Cleveland and also at other National Weather Service office, they can see the differences there. They know that something, okay, I know the radar is trying to fill in what it can't see, and it does that sometimes, and it makes it appear like the storm is weaker and we don't have the detailedness. That's where the spotters come in. That's where the emergency managers come in. That's where the spotter, that's where the public comes in. A lot of times we get people take pictures and they put them on, and yeah, we're getting more reports in the last 15 years than we've had in the last probably 30 or 40 years, because everybody takes, have a phone around. And so the beam broadening and the beam fanning out does kind of has the appearance of the storm is weaker farther away, but that's not the case, and that's why we need spotters. So the public is more likely to heed a warning if they have an actual report. The old legacy products that we issue, the severe thunderstorm warnings and the tornado warnings, definitely if we have in the warning, spotter reported a funnel cloud near a location and radar indicated, that's a stronger warning. And you have two confirmations there, people are going to take action. That's the type of message that we want to receive. That's the type of message we want to send out. Unfortunately, we're not asking you as a spotter to stay up late at night to go out and look for things. It's actually because we have a spotter network that's wide ranging, and in all the counties in our area, the opportunity of something affecting you in your backyard, that does help in that situation, and it helps as far as the reporting. We don't want you to go out and go out seeking, getting out of your normal situation as far as seeking and looking for stuff that's 30, 40, 50 miles away. We want you to stay in your one location unless unless the storm is affecting you and you have to kind of take cover, then that's a different story. We're going to talk about how to remain safe and observe these type of weather phenomena, and definitely these tornadoes and severe thunderstorm and stuff like that. So National Weather Service warning plus ground truth equals public action. We also we talked to the emergency managers, not only the Ohio EMA, but also local emergency managers. I was actually looking on here, I saw Portage County deputy on here, and I've been looking at some of the other people on the list. So we have some emergency managers on here. I know we have some ARIES on here as well. Actually we have tomorrow, we have a amateur radio that's actually coming in to kind of set up and make sure everything is working in anticipation of our severe weather season that's probably within a month away. So that's going to be in the works. So we'll be prepared this summer. We'll also work with the TV stations, most of the media markets. We have CERT, PEMA, Pennsylvania Emergency Management Agency, work with other National Weather Service, especially if a storm is moving from Pittsburgh area into our area, coming in from the south, maybe coming in and approaching Youngstown. So we actually talk not only to other partners, but we're talking to other National Weather Service offices as well. What we're trying to do is actually kind of have that convey that similar message or same message to encourage public action. That's the name of the game here, and that's what we're trying to do. So what makes a good spotter? Good spotter, we want to make sure that they're safe, safety and preparedness, where to get weather info, how to identify thunderstorm features, and how to submit an effective report, TELL. And we'll talk about that acronym a little bit later, but let's go into some things as far as watches and warnings. National Weather Service issues watches, and you see them all the time. They've actually been to the south of us and actually to the west of us across Iowa and across the Mid-South and Deep South. We haven't had any watches here I don't believe this year. I think we may have one or two, but not as many as they had down south. Our time is coming because we're starting to get a little warm. Springtime, definitely that is coming. So for severe thunderstorm watch, damaging winds, gusts are possible, large hail and isolated tornadoes. In a tornado watch, tornadoes are possible, damaging winds and large hail. For both of these, severe thunderstorm watch and tornado watch, they are issued by the Storm Prediction Center that's located in Norman, Oklahoma. Flash flood watch, water flowing over a roadway and rapid rise in water that is a threat to life and property. That is issued by the office, issued by our office, but also we in conjunction actually have some coordination. Sometimes we have some coordination with the Weather Prediction Center, which is located in Silver Springs, Maryland. So severe thunderstorm warnings, that's definitely when we're expecting imminent or it's occurring. That's actually when we're expecting thunderstorm wind gusts of 58 miles per hour or hail 1 inch in diameter or larger. Tornado warnings, Doppler radar indicated or confirmed report of a tornado from a spotter, emergency manager, or public. And then flash flood warning. This is subjective, 6 inches or more flowing water over roadways and rapid rise in water that is a threat to life and property. All of these warnings originates from our office here at the National Weather Service in Cleveland. I want to go into a little story. You've probably already seen this if you're on Twitter or social media, Facebook, and some of the offices, some of our neighbors to the south, even my previous office that I had, they actually have the trinity: celery, onions, and bell peppers, rice, sausage, and maybe some seasonings, and they have it all on the table. And they will actually say, okay, that's a watch. And then you put all that together, you have jambalaya, that's a warning. Now I've been doing this guy warn for about 20 years. I kind of equated to my lifestyle as far as when I was growing up in high school. When I was in high school, I grew up in South Florida, and believe it or not, we had cow pastures down there. And so, there's nothing to do when you're 17, 18, there's really nothing to do. So I would go outside and I I would go outside with my friends, and we would, at night, we would go cow tipping. So the idea of cow tipping, you would actually go at night when the cows are sleeping and they're standing up, cows and bulls, and we would actually go over to a cow and push that cow over. The idea of us entering that field is the watch state. So we're doing something we have no business doing, but it's kind of the watch state, and we're kind of in the watch state. Once we push that bull over, that bull charges us or run after us, then we're in the warning stage. The action that we're taking is running. That's the action that we want the public to do. We want them to take action, to take cover. And so at that point, I got the warning, even though I initiated it, then I'm taking action. And so that's the whole idea there. I've seen some others, they have cupcakes, they have flour, eggs, butter, milk. Did I miss anything? Oh, sugar, of course. And maybe some powdered sugar. And then they put it all together, then it's a cupcake. So they have all the ingredients on the table. Watch, cupcakes together, warning. And I guess the action on both of those food products is to eat it. So that's the action. So that's the kind of the short synopsis of a watch and warning. Do we normally follow that? We like to say most of the time the weather does follow. The watch, severe thunderstorm watch comes out, the severe thunderstorm warning comes out, you take action. I'm going to show you some examples where that did not happen, and so we're going to cover that in the second half of the second hour. Here's what we do as far as safety and preparedness before the watch is issued or while the watch is issued. You stay tuned for weather updates. Be ready to report to the National Weather Service. Consider yourself on call. This is a watch that's issued, a tornado watch from Indiana and across Ohio. I think this is from the November 5th, 2017 event. And if you if you've been at Sky One before, online last year, this is the same event. Do not go outside and film the storm. We say that, and yet, a lot of times we can't. We use a lot of the pictures in our Skywarn, or we see it on social media. We accept those reports, but as a federal employee of the National Weather Service, I'm to tell you, do not go outside to remain safe. We want you to remain safe. We don't want you to be a chaser. We want you to be a spotter. And so we want you to remain safe. If a severe thunderstorm warning is in effect, seek shelter in a sturdy building away from windows and monitor for possible tornado warnings that may be issued later, or if the storm is upgraded. In a tornado warning is in effect, go to the basement or an interior room immediately. Get into a tornado safety position under a sturdy, something that's sturdy like a table, and stay in place until the warning expires. After, we want you to remain safe. Your safety is your first priority, so do not rush outside to find damage. Possible damage includes downed power lines. This is very dangerous in the fall, especially when there's a lot of leaves that are down. You may not even see the power lines that are down. That can be very dangerous. Lightning that could occur on the backside of an anvil as the storm is exiting, that can be very dangerous as well. I think most people, when the thunderstorm is overhead, people seek shelter, but then they kind of say, well, we haven't had any thunder in 5 or 10, lightning in 5 or 10 minutes, or I haven't heard anything in thunder in about 10 minutes. Is it safe? It's a good idea to wait 20 to 25 minutes, maybe possibly up to 30 minutes. If you don't hear anything, that thunderstorm has moved away, and I think that's probably a safe situation. Trees and water across the roads, that can be a very dangerous situation as well. And weakened structures, unfortunately, if you're in a weakened structure that's been hit, you have to get out some way. That's probably a good idea to wait for first responders to help you out in that way, or find a way that's safe in that structure to get out and get away from that weakened structure. So there's different ways to get our information. You can actually go to our website. That's actually www.gov/CLE. That'll get you to the front page of our website. You'll see our forecast area. You kind of click on the area. You can go to Youngstown or Canton, you know, or you can go to different locations to actually find the forecast that you have. We also have Weather Story and other things. You guys registered through the local programs and our Skywarn page to get that information. So you guys are pretty much familiar with it. But if you're not familiar with it, definitely it's a lot of information, kind of information overload, but it takes some time to go through it. You can find information. You can give our office a call, you know, in the business hours to kind of go over some things if you're trying to seek some information, climate information, how to read different information. Where can I get, you know, where can I get the marine forecast for Lake Erie? So that may be something, and we can tell you how to do that. It takes a little bit of time to get familiar with, but once you get the hang of it, you'll be able to find information, and we're always adding information. These guys are loaded the climate information up. There's some new climate information in there, just chock full of a lot of information there. We're also on social media. So we're also on Twitter. Twitter, you know, for us, Twitter, we use it as a data mining situation. We also, you know, we follow all the TV stations, all the, you know, the emergency managers that are online. We follow the Highway Patrol, the Ohio ODOT. We follow them as far as seeing reports of snow on the interstates as well. So we use it in different ways. We also issue a lot of our products on Twitter as well. This is the fastest way, and probably, you know, if you follow us on Twitter and get that alert, you definitely get all the information from us anytime we issue a flash flood watch, like the example here, or any kind of short fuse warnings like tornado warnings or flash flood warnings or severe thunderstorm warnings. You'll see that map and the location and the threat that's there. So you also see maybe some radar information that we'll include in there. In a slow day like today, wind advisory, that information will be there, but also some interesting information will be pushed on there. We're also on Facebook. If Facebook's a little bit slower, sometimes, as you notice, if you follow certain people on Facebook or certain entities on Facebook, you may not see those posts all the time. You have to go to the actual page to see some things, depending on, you know, if there's a lot of traffic, a lot of likes and stuff like that. So it's kind of governed by the algorithm, and depending on how much you interact with a different page or our page or anybody else's page, you may not see the post if you don't interact with that page. But if you're interacting with the National Weather Service, you'll see most of our information that's on there. It's a little bit slower pace, so you're not going to get the fast-paced warnings on there like on Twitter, but definitely you'll get a lot of information there. You also get the Facebook Live. You know, one of our forecasters during the winter months, he actually put a lot of information on there as far as going live, showing where the storms were, the snowstorm, where the squalls were occurring, and that was very helpful. We had views of up to 15 to 20,000 people, almost over 1,500 people viewing it at one time. And we're also on Instagram. You know, Instagram is a kind of a storytelling kind of a series, and we're using it now for slower situations, but also we may be using it for storm surveys, and we're going out to kind of tell those stories and stuff like that. A lot of information, not fast paced, a lot of storytelling, and also maybe using it for storm surveys and information as well. The website, definitely, if you guys are familiar with it, if you want to get to information as far as spotter information, you will actually go to the first tag for current hazards and go to local outlook. That will get you to our hazardous weather outlook to get a lot of information, but also it'll get you information as far as going to the Storm Prediction Center. So we'll go over that as of next. So the Storm Prediction Center is a layered agency that's on top of the National Weather Service. They're more or less giving a convective or thunderstorm outlook threat across the United States from day one, like today, all the way through next week. And so they give you like kind of an information. They have like different categories, and we'll go over those different categories. But you can see they give you a little threat, whether it's general thunderstorms or marginal thunderstorms. Definitely a lot of chock full of information there. We give this information. Sometimes we may tweak this information a little bit closer zoomed in to northern Ohio and Northwest Pennsylvania, or the state of Ohio. Definitely a lot of information there, a lot of archive information as well. Watches are on there as well. Updated information about the watch, storm reports from the previous days. That information is on there. A lot of chock full of information. They keep up with fire hazards as well. The Hazardous Weather Outlook, that is a product that we've issued. It's a kind of one of our older products. It is a way we talk to the emergency managers and give them information as far as impacts that's occurring from day 1 and occurring out to day 7. So a little bit more detail for day 1, today and tonight, then a little bit less detail day 2 through 7. But we can talk about, different features that may be affecting the area based off the guidance from Storm Prediction Center and based off our expertise of the area here. So we may see something that Storm Prediction Center that is not looking at or maybe overlooking. That happens sometime, and I'll show you an example of when that happens. The bottom section there, spotter information statement, that's when we're talking to you guys. That's when we're kind of laying out, hey, we need reports, snowfall reports, maybe rainfall reports, or maybe it's time to be activated to be, to be in a situation of a watch mode of not, having your ears up, perked up, be on the call, kind of looking out for things. That information will be there. As far as the Storm Prediction Center, definitely a situation where they rate the different risks of thunderstorm as far as severe weather. From the left-hand side, the light green, non-severe, those are kind of just general thunderstorm. We know lightning kills, but definitely not expecting anything that's severe. These are sub-severe, winds less than 40 miles per hour. There could be some small hail, but for the most part, not expecting severe weather. Marginal risk, a little bit higher as far as winds and hail, low risk of tornadoes, very low risk of tornadoes most of the time. Slight risk, actually kind of amping it up a little bit. And I'll go, just going through, kind of stepping through, you can see it's actually increasing as far as the actual coverage and also the threat levels and the damage level goes up as you go higher. You can see the high risk, widespread severe thunderstorms, tornado outbreak, and a derecho. Different ways of receiving our information on your mobile device. Unfortunately, we do not have an app. The National Weather Service do not have an app. I know there are actually apps that are out there that use our logo. They are not us. We cannot send out a cease and desist and they use our logo. And if that, we actually received calls in the office. Hey, your app is not working. And then we tell them, we don't have an app. Well, that's your logo on it. And unfortunately, we can't, we don't have an app at this time. We would like to have an app and interact with people, but at this time, we don't have an app. FEMA does have an app. You have different ways. You can actually go to the store. It says BlackBerry phones on there, and it should not say BlackBerry. They just retired BlackBerry last year. I remember that. So it's on the Android and Apple store. And Red Cross also have alerts and apps that you can use. They also have a tornado watch and warning alerts on there as well. The wireless emergency alert system, that's that's when we get on your phone, you get the Amber alerts. That's kind of the same thing. We have tools to utilize the wireless emergency alert system that's built in most phones, probably 95% phones, and actually some of the flip phones have this technology as well. It will alert your phone anytime there's a tornado warning that's out, flash flood warning that has considerable tags or destructive or catastrophic tags, and now severe thunderstorm warning that have destructive tags. And you might be wondering, wait a minute, you guys issue a lot of severe thunderstorm warnings. These are for severe thunderstorm warnings that have destructive winds of 80 miles per hour. These are situations where we have derechos or thunderstorm complexes producing very strong winds. These are destructive winds. These are causing roof damage. Rigs are being flipped over or turned over on the side, especially if it's moving north or moving south and those winds are coming in from the west at 80 miles per hour. Also, it covers baseball size hail or 2.7 to 7.5 inches. I don't know if you guys have kind of been following on Twitter. You saw that bear claw hail that was in Texas. Oh my God, that that hail size was, I don't know, it looked like a bear claw, like a apple fritter with powdered sugar. I'm a little hungry, but it was a huge storm, a huge hailstone with a bunch of hail. That's actually, that type of hail can kill cattle, and that's why it has a destructive tag. We utilized the destructive tag and the WIA alert for a storm that was actually west of the Cleveland area for Lorraine. And at that time, we publicized it last year with all the emergency managers. Also, we publicized it with a lot of the online spotters. But I think a young lady received the alert, and it was odd to her because she said, well, I normally don't receive this unless it's tornado, so I guess I better take cover. She took cover in her basement, and 3 trees crashed on her house. And she said if she did not take action, she would not have, she would not be safe and able to talk about it. We don't know what would have happened, but definitely going to the basement and taking cover saved her life. Flash flood, that has changed 2 years ago, considerable and catastrophic. Those type of floods where there's water rescues going on. There's not a dam break that's occurring. Water is flowing, definitely not only over the road, but it's also widespread. Catastrophic, a situation where definitely there's water rescues. Not only that, subways flooding like we had in New York last fall with the remnants of a Hurricane Ida. Definitely a very dangerous situation. No Other Radio is still around, and we still using. I do these talks, and like a tape recorder, you can pick up these No Other Radios at Radio Shack. And then I backtrack. Oh, I can't say Radio Shack anymore, but you can get them at department stores, also at drugstores as well. You can also pick it up on Amazon. They're programmable to the FIPS code, the county codes. So if you want to program it for all the points to your south and west, where a good majority of our storms are coming from, you can program it for that and your county. And it actually alerts, kind of like like the old, like the phones, or the alarm clocks. It will just alert you. You have a battery backup, so if the power goes out, you still get the alerts. Total alerts for warnings, and so that is very helpful. Some people, they go out, they go hunting, deer hunting. They have it on their hip like the old brick cell phone. They get those alerts as well. Especially if you're out of cell phone coverage, you definitely get those alerts on your No Other Radio handheld device. So now we're going to talk about thunderstorm features and definitely the ingredients that comes into play, the life cycle, the different types, hazards, and cloud ID as far as identifying what you're looking at as the storm. Definitely the atmosphere, there are definitely ingredients for a thunderstorm. You definitely need moisture, instability, trigger. So for thunderstorm, you need those 3. For a thunderstorm that's gonna last a little bit, maybe possibly severe storms, you're gonna need some wind shear. That's changing of wind direction with height. Also, the winds increasing with height will also help that storm kind of move and not choke itself out as far as the inflow going into the storm. We'll talk about that a little bit later. So the thunderstorm cycle, definitely in the beginning, you're getting into that towering cumulus stage. You're getting that warm eddies is moving up, condensing, and developing a cloud as it moves up into the atmosphere. You see these in the summertime. They're kind of going up. If you're kind of sitting back and you have one of those days, I don't have too many days where I can sit back and sip lemonade and sit on the back porch. But if you are actually doing it, you can see these growth and occurring around 9 or 10, 11 o'clock and developing over time. The atmosphere has to be right and the conditions have to be right for moisture, instability, and also some kind of lift, some kind of front or warm surface that's actually lifting. They're actually rising because of the surface of the ground is heated up. In a mature stage of a thunderstorm, definitely not only have the upflow or the updraft that's occurring, but you have the downdraft. So you have 2 actions that are going in a mature stage of a thunderstorm, the updraft and the downdraft. The downdraft is where most of the rain is going to occur, and possibly maybe some hail, some wind. Definitely that's where the downdraft is occurring, where all those ingredients are occurring as far as the impacts of a thunderstorm. Then you have the dissipating stage. The updraft has dissipated and it's just dominated with a situation where the storm is kind of raining itself out. This is very dangerous because a lot of times when we're thinking a storm is kind of, dissipating, there still could be some anvil lightning that could occur out of this. So this needs to be very careful on this. This situation, a lot of time is occurring around 6, 7, 8 o'clock summertime. You see a lot of debris. They make a nice sunset at times because the sunshine is, the sun rays are kind of underneath the cloud deck. And these, it's around probably 35, 40,000 feet. So it does light up the bottom side of those clouds as it's dissipating, the amble debris that's occurring. So this is what the role of the wind shear is showing of a severe thunderstorm. Definitely, near the surface of the ground, you may have that warm, moist air that's moving, maybe, just an example, moving in from the southeast, maybe south. And then you have winds there as you go up a little bit in the atmosphere, maybe at 4,000, 5,000, 6,000. Maybe the winds are, maybe coming out of the southwest, or are they coming out of the west? They're also increasing with height. So not only, it could be, 15 miles per hour at 5,000 feet, maybe 20 miles an hour at 10,000 feet, maybe 35 at 15, and so on. So that type of shear gives the opportunity for the thunderstorm to kind of persist, kind of progress in one direction. This is where the steering currents of the storm is, especially around 7 to 10 to 15,000. That direction of the wind is actually going to tell you where that storm is going to be going. And we kind of use that kind of early in the day to kind of see which the direction the storm is going to be moving. In the flow that's going up, sometimes you get new cells that develop. You can see some of those storms in the red lines that's moving up the storm. Also, as you continue to go up into the atmosphere, into the storm, you get a situation where there's flattening out. And so what's happening there is actually getting to the top of the atmosphere where most of the weather is occurring. You're getting to the tropopause. It's actually just an increasing portion where the temperature is increasing finally. So you go up in the atmosphere, it gets cooler, and then it gets to a point where the temperature stops cooling and starts to get warm. And so that's why it's flattening out. And then if you, by any chance, you see an overshooting top, that should tell you that storm has very strong updraft that's going on. Just kind of popping through that tropopause. You see that. You may not see that in Ohio. You see it more or less out in the western states on the plains where it's a little bit drier. You can see a lot of features, but believe it or not, those features exist here, but we may not be able to see it because there's so much moisture around. On the backside where you have the blue lines that are actually kind of showing the downdraft, you also see this situation where the winds are kind of proceeding or actually kind of flushing out and going towards the front of the storm, kind of lifting that warm, moist air. A lot of times you may see a shelf cloud or a roll cloud develop that's on there. So we're going to talk about that in a little bit, probably in the second half. So this is kind of a spectrum. It's not very clean, but spectrum of the thunderstorm spectrum. You get your pulse type storms, single storms. In the middle, you get clusters, multi-cell, squall line. You get those type of storms. It's all based off the shear, really, as far as the winds increasing with height and turning with height. And then you also get your supercell. As far as a general thunderstorm, those single cells generally are non-severe, possibly severe for the cluster, multi-cell, and squall line, definitely for the wind, and possibly heavy rain. But supercell is going to cover all the modes. We're going to talk about that in a little bit as we talk about wind shear. So in the wind shear, weak shear, definitely a situation, summertime, these storms go up and they fall back down. These are single cell, maybe multi-cell. Sometimes they last 30, 40 minutes. Strong shear, definitely a situation, winds moving out of the south and kind of veering with height or actually turning to the southwest and west as you increase up, as you go up in the atmosphere. These storms kind of live a little bit longer. They're kind of moving, they have a direction they're moving in. They're marching maybe from west to east or northwest to southeast. You see this, especially in the summertime. And then you have extreme shear. It's a situation where not only you have strong lower level winds at the surface, a little bit above the surface, coming in out of the southeast, maybe south. Those winds come out of the west as you go up to 5,000, 10,000. They're very strong. And this promotes a lot of supercell storms. Not only you have storms that are developing, but they also the whole storm is rotating as well. So those are supercells, and all modes of severe weather are present. Single cell thunderstorms, those pulse, garden variety types cells. The main threat's going to be heavy rain, maybe wind, maybe hail, but heavy rain in a short duration of time. These storms last about 20 to 45 minutes. They have one updraft and they fall down, and a lot of times they choke themselves out. You know, they're falling right on the updraft and the storm is gone. So this is kind of summer type, very light winds aloft, very light winds in the upper parts of the atmosphere, not only at the surface, but they're light at 5,000, 10,000, 15,000. No direction. The storm is not moving less than 5 miles per hour at times. This is what you see in the field. Definitely looking at a rain shaft in the middle of the screen and a thunderstorm that's developing. It doesn't have too much of a direction and moving. If this was in motion, you would not see it moving pretty much at all, and it'll rain itself out and get to the dissipating stage. So this is a multi-cell. Definitely the threats are there for wind and hail, but heavy rain is definitely a situation because you could have a situation where storms are developing and moving right over the same areas. You could have a training situation that's going on. Tornado threat, it may be there, but it's still somewhat low. I think the main issue is going to be flash flooding with this one. Downburst winds possibly definitely will be there, and small to medium-sized hail could be there. That could be an issue, but the heavy rain is definitely going to be the dominant impact, dominant threat. Here's a situation kind of out in the cornfield looking at cells, and you have all the life cycles here. You have new storms developing and towering cumulus to the right, mature storms, strong storms develop that are in the middle here, and then also weakening storms to the left where you have the anvil kind of, it's raining itself out, it's in the dissipating stage. So definitely a situation where you have different cycles going on, or different life cycles that's going on, multi-cluster cells that are going on. Here's an example of what we're looking at, moving across northern Indiana and extreme northwest Ohio. And at times, looking at this can be very difficult to kind of know which storm is severe and which one is not. That's where you guys kind of come in to play. And, believe it or not, we get reports, Twitter, somebody take pictures of hail and stuff like that. We have guys that are looking at that all the time. Well, we have forecasters that are looking at that, looking at kind of data mining the social media to kind of look for certain things from you guys. And if you're tweeting it, if you're putting it on social media, or if you're giving us a call. Here's a multi-cell squall line. An example of that would be like a derecho. This is probably the main threat for a derecho. That's a thunderstorm complex that's long-lived, that's tracking across possibly 400, 500, 600 miles across the Midwest and going to the Atlantic states. The wind is going to be the main threat here. Heavy rain, definitely going to be a threat, but it's going to be short-lived. Wind, and to believe it or not, you're going to have hail, but your hail could be driven by the wind. It could be a situation, not only you have hail falling, but hail being driven by the wind. That can be a very dangerous situation, especially not only for the roof, but the side of the house could be attacked by hail. And that's a very dangerous situation. That hail hurts as far as if you're caught outside and that stuff is hitting you, and it could cause a lot of damage. Heavy rain, short duration, that could be an issue. And these spin-ups that could occur right on the edge of the squall line, that could occur as well. So the threat's definitely heavy rain, and wind-blown hail could be a possibility as well in a type of multi-cell squall line or derecho. This is what we're looking at here. We see on radar, it looks like a cluster that's moving into Pittsburgh's area, and they've issued a very large severe thunderstorm warning for several counties that extends from our area all the way down to West Virginia or Charleston's area for a southeast Ohio. This is what we look like in the field. It look like I'm looking at possibly the roll cloud and maybe that gust of air that's coming in. We're going to talk about that a little bit later. Supercell, all threats are there. Wind, hail, heavy rain, and tornado. Remember, this supercell has a life cycle or its own environment where the whole storm is rotating. It's responsible for the most significant tornadoes and hails as larger than golf ball. Extreme winds can occur with this, especially when the storm is collapsing, and flash flooding that could occur. So all threats are there. Here's what we're looking at in the field. You see the anvil to the top left. It's kind of a little bit, a little bit moisture in the area, but definitely you can see a lot of features here. The schematic showed, I didn't describe what was in the schematic, but I'll go back to it. And it's showing the overshooting top, the anvil, the cumulonimbus, the spine of the storm, the updraft where it occurs with a wall cloud and tornado, the rain shaft is to the right. A lot of hail may occur there. Maybe that's where your shelf cloud is. On the back side or the left side, that's where new storms are possibly going to form. The rear flank downdraft, where it's the flanking line is developing. You could have something that develops, new storms developing there. So this is what it shows like it in the field. Definitely you got the updraft tower that's right above the wall cloud, the rain precipitation shaft that's to the right, rain-free base with the rear flank downdraft or flanking line there. Possibly new storms could develop there, maybe not. That could happen, depending on how much moisture is present in this atmosphere. Here's another one here. Looks like the whole storm is rotating. This looks like something out of the this 1977 movie that I saw when I was a kid. Was it the First Encounter, the Third Kind, or something like that? Yeah, back in 1977. Looks like the whole storm is rotating. Look like a big spaceship. And you see a situation like that, you definitely have a supercell on your hand. That's a very dangerous situation because remember the supercell is responsible for the hail and the dangerous as far as the significant tornadoes as well. This is what we're looking at here. Reflectivity on the left-hand side showing the precipitation, but not only showing precipitation, but it could be, we can examine some other parts of the storm, but it looks like it's showing the traditional hook echo or the kidney bean, definitely showing the rain that's in the middle, that white and pink that could be, not only showing rain, but it could be hail, but it could be debris, it could be all kind of things that are run up. Once we got the dual pole, we were able to indicate what kind of stuff was in the storm. And actually, when we see this signature, you may have heard some of the, not here per se, but maybe sometimes here, you hear this talk of debris ball, and it's actually debris that's being sucked into the storm and being thrown up into the storm, sometimes getting up to about 15, 20, some storms getting up to 30,000 feet. Debris, scrap metal, stuff like that thrown in. On the right-hand side is the velocity, showing what's moving towards and what's moving away from the radar. And if those signatures of moving towards the radar are very tight together, there's a couplet, that's a good indication that circulation. So with both features, it's a good indication that we probably have a possible tornado that's on the ground or was on the ground because of the way the radar detects different type of phenomenon as far as debris. Straight line winds definitely outflow from a thunderstorm that blows in one direction. Sometimes we get calls from emergency manager, hey, we got a lot of trees down in this area, and more than likely they've been trained to say, but it looks like it's blowing in one direction, and it may tell us, hey, this looks like straight line winds, but man, they really blew down. When you see this, people automatically think, oh, a tornado caused this. A lot of times thunderstorm wind gusts, straight line winds, downbursts, and microbursts can cause this type of damage, and it can be widespread. Tornadoes more narrow, kind of have a very fine defined track, whereas this type of damage is going to be widespread, but less extreme. This is the derecho thunderstorm complex that moved across from Iowa to the Tidewater area of Virginia. Winds associated with it was 100 miles per hour, and it moved around 600 miles for 10 hours. So definitely affected the central portions of Ohio. A lot of power outages. I think the main threat is going to be wind damage with this one here. We looked at the reports that came across. Those two tornado reports that were on the edges of this thunderstorm complex, this squall line that moved through. There were definitely 870 wind reports, and 36 of them were 80 mile per hour or greater. Some hail reports about 57, total reports of 930. To put this in perspective, last year we received, of all our reports of tornadoes, wind, and hail across the state of Ohio, we had about 450. So we had a kind of a low year from this one storm. 930 reports. Of course, it spread from Iowa to Virginia, but definitely a situation where there were a lot of reports, a lot of power outages, and this can be kind of tenfold, especially if it's warm afterwards and residents don't have power and it's hot, and you definitely have a double whammy. People suffering from heat exhaustion, heat as far as extreme heat that could occur that may be at a lesser level because people don't have AC. Hail, definitely a situation where those updrafts are kind of bringing those water droplets up, they freeze, then they get too heavy, they fall back down, and maybe they get caught back in the updraft again, so they take a second trip up. The hailstone gets larger, and then it falls back down. Well, maybe it takes another trip up. The updraft is strong enough, it takes another trip up. And so we can kind of tell if it's P to probably maybe a little bit smaller and dime-sized hail. We know that hailstone maybe has taken one trip up. If it's getting a little bit larger, maybe quarter-size hail, it may have taken two trips up. It's getting a little bit larger to maybe baseball-size hail, like this stone that's on the right-hand side, upper right. That's it's three trips up that could have occurred. If it's that bear claw thing, I'm not sure how many trips that stone took up and down, but definitely anytime it's taken 2 or 3 trips up, that large size stone, that's telling us, that should be telling you, if you get a stone that large, that storm has a lot of updraft. It's enough to hold that type of stone up in the air for a long period of time. I will say this, in the summertime, a lot of storms that you may think it may look like it may have hail, or you may be caught out there and you get these water drops that are very cold. A lot of times a lot of storms do contain hail, but they melt before they reach the ground. That could happen because that air is collapsing from the upper parts of that storm, and so you can get this flushing out, especially if it's a gust front or the leading edge of a squall line that's kind of pushing through. You've been in a situation where you're outside and you're taking cover, but the storm is up on you, and all of a sudden you get this roll cloud that's moving through, this large shelf cloud that's moving through, and you get this cool gust of air. So you're sitting at 85, and all of a sudden it goes to 65. That storm is collapsing, and it's actually pushing that cold air, not only rain droplets, but also wind and everything that's pushing out. It can be refreshing, but it also can contain some hail, and it's actually your situation is going to deteriorate because the storm is approaching. Flash flooding definitely caused by localized heavy rain from thunderstorms of 3 to 5. That's subjective. It depends on what type of urban areas, depending on whether an area can hold water, whether it's a swampy area. It really is subjective how flat the area is, depending on the drainage. Impacts washed out roads, bridges, forced evacuation, and definitely structure. Bridges washing out, roads washing out. Here's an example of somebody with 6 inches of rain, 6 to 8 inches. This is a truck. If the water is covering the road and you don't know the depth, turn around. Don't drown. That's our logo. This is a truck situation where I think there's individuals abandoned the truck. They couldn't go any further, and the water is taking it away. The water is covering the road. I'm not sure if the bridge is out, but it looks like a water crossing rather than a bridge, but definitely the situation where the water flowing, taking that truck away. Lightning, we do not issue severe thunderstorm warnings for lightning, no matter how vivid or impressive it is, but it is deadly. You know, it has taken a generation for this country to actually heed the warning. I can remember jogging or on a football field in the 70s and 80s, and we're practicing, it's lightning, it's thunder, and we're still practicing. That does not happen today. Anytime there's, I think most high school and even the golf courses, they have the lightning detection, and it'll detect and tell people to get off the field. Soccer fields the same way. They take a lot of precaution now as opposed to 30, 40 years ago when there was a lot of lightning strikes that occur. The deaths have went down, but still there's still people that get struck. If you have a situation that lightning strikes a tree, the tree is damaged, or it causes a house fire, definitely report that to us. But anytime there's vivid lightning like that, no, there's probably not a need to report that to us. Is a tree that's struck by lightning definitely splintered in that situation? Another image of lightning, no matter how vivid it is, you don't have to report it unless it's causing a fire or any kind of damage. So we talk about the threat list as far as approaching of a storm and the exiting of a storm. That's the most dangerous portion of a storm, because what's happening is people are not, they're kind of slow to take cover. The storm is approaching, but that is a very dangerous situation as the storm is approaching. Most people will take cover, and when the lightning risk is high and the thunderstorm is overhead, okay, I'm out of here. I'm going into a building. It's when the storm is approaching or leaving the area, that's when it's very dangerous. And tornadoes, a violent rotating column of air extending from a thunderstorm in contact with the ground. That's the definition we work with. That's been the definition for a while. You got different features here. The United States sees about 1,200 tornadoes annually. And if you've been paying attention, last March, we've had a ton of tornadoes this past 6 weeks. Some areas down south, as forecast areas that kind of equivalent to the Cleveland area, have seen 50 and 60 tornadoes in a 3 to 4 weeks time span. Our area only averages 6 per year. So that is a lot of tornadoes, and there's some years that it's pretty low, and some years that we get pretty active. And we're not immune to not seeing some of those strong or violent tornadoes. So I don't want, we haven't had too many, but, we've had tornadoes, and they can, one hits your house, one hits your business, that can ruin your day. And those weak tornadoes can kill. So we're not taking it lightly for the tornadoes around here. We're going to issue warnings anytime there's a tornado indicated, or if a spotter sees one or reports one to us or to the emergency manager. So we talk about the EF scale. That's definitely how we rate the tornadoes as far as the damage that we see. We have scales as far as damage on trees, what type of trees is damaging. But 77% of the tornadoes of EF0, EF1, those are weak tornadoes, 65 to 110 miles per hour. They're short-lived. They're less than 3 miles. They can persist a little bit longer than that. They develop quickly and occasionally without warning. So we had one earlier this year in Huron County, lasted on the ground for 2 minutes. It was gone. And that was the EF0 tornado. Those are type of situations. Yeah, we need help for those type of situations. We could see them, but they're gone. And radar sometimes you only have one scan. That's when the radar is rotating around and seeing it, and it's gone. So they don't persist for too long. The EF2, EF3, those are your strong tornadoes, 22%. That's kind of a situation where 22% of the tornadoes that we see across the United States lie in there. I think that number is probably a little bit lower for Ohio. I have to look at those numbers. We're going to be looking at those numbers a little bit later to kind of see what the national average is and how we compare. 111 to 165 miles per hour, generally lasting longer and tracks up to 15 miles per hour. Better detection. It's been a long time. Even my old office and this office, we don't miss EF3s. It's been a long time since that's a situation where even 100 miles away, normally when you have a thunderstorm that has a tornado that's somewhat stronger, EF2, EF3, you definitely get circulation up to 20,000 feet, and that's going to be captured for most of our, pretty much all of our radar coverage. EF4s, EF5, less than 1%, they're responsible for most of the deaths. These are the killer tornadoes. Their tracks are 20 to 50 miles. They could be longer than that. It could last longer than an hour. The tornado that occurred across Kentucky lasted longer than 2 hours, 160 miles, 166 miles per hour to greater than 200 miles per hour. The state of Ohio averages around 19 tornadoes. The state of Pennsylvania averages around 15 tornadoes. You can see Texas kind of leading the pack there. These numbers are from 1985 to 2014. So when these numbers are updated, I'm wondering if our numbers are going to go up or down. We have to see on that one. As far as per square mile, the state of Iowa gets more tornadoes than any other state per square mile. I will say this, the actual, the advent of the cell phone, digital phones, or, digital cameras, cell phones, and now social media, we're getting a lot more reports of a lot of things, not only tornadoes, but hail and stuff like that. Whereas before it would kind of, sometimes we didn't get the reports, but we had to get the reports from newspaper clippings back 20, 30 years ago. As of now, if we get a tornado on the ground, it's on social media yesterday. So it's very quick. Here are the weather disasters across the country for 2021. We had a big hailstorm that was southeast of Dayton, Ohio, that caused $1 billion worth of damage. We have to take hail and thunderstorms seriously. Severe thunderstorm warnings, we issue a lot of them, but when they're dangerous and we have that WIA and we have that destructive tag on there, it's time to take warnings. $1 billion worth of damage from a hailstorm. That's mostly cars and homes. No, luckily nobody died from it, but there were some injuries from that. You can see most of it's from severe or outbreak across the Midwest, tornado outbreaks in the Mid-South. We even have some winter storm that's across Texas that occurred last February with those sub-zero temperatures through a good deal of Texas. That's probably more than a multi-billion-dollar damage there. Fires out west, definitely coastal California had flooding as well and severe weather. So these are all the maps. You can get this on the Climate Prediction Center page and get all those information there as far as the disaster. They update this every year, and I think it's out around March. So for the state of Ohio, I talked about the total number of reports across the state of Ohio, about 464 reports for the whole state. 400 reports were wind. Wind is going to be the dominant. That's caused by severe thunderstorm warning. Hail, definitely had 27 reports of hail, and also tornadoes. Remember I said 19. Last year we had 37, so we didn't have a lot of severe weather. Remember, our season was slow to get started. I mean, we went kind of to spring and snow on Mother's Day, and we went straight to summer. We didn't have much of a severe weather season across here, but the surprise we had was in October with the secondary severe weather peak. And we'll talk about that in the second hour. Portage County, as far as the tornado history, since 1950, these are reports from storm data. We've had 16 tornadoes across the area, no fatalities, 2 injuries, and I have that $507 million on there. That's actually included from a track that occurred from the 1985 tornado, the F5 tornado that moved across eastern portion of Portage and into Trumbull County. So outside of that tornado, because it looked like it started in Portage, but most of the damage was done in Trumbull County. We're going to talk about the actual storm that occurred that was in 1973, and if you include that storm, looks like that was an F3 tornado that occurred in June. No fatalities, but 1 injury occurred with that one. outside of that monster that occurred in 1985 that was in Trumbull, and I didn't see any, look back at the history, I didn't see any injuries or deaths that occurred with that storm in 1985. It looks like that the one that's the strongest that's near north of Kent was your strongest storm. From Mahoning, since 1950, 16 tornadoes, 3 fatalities, 15 injuries. Property damage about $5.4 million. The strongest tornado occurred June 3rd, 1963. 2 fatalities and 0 injuries. I'm not sure. I need to check on that just to make sure. A lot of times the fatality numbers, injury numbers are higher than the fatalities, but looking at the reports, that's what the report said. So, if you're in Mahoning County, if you have more reports of that, if you're looking at newspaper clippings, you can get that information. And that storm that caused that F3 was actually in the northern part of Mahoning County. It actually touched down in Youngstown near Gypsy Lane and MLK Boulevard. That was on August 5th, and I have June 3rd on it, but it was actually August 5th, 1956. That tornado intensified as it moved south for about a half a mile before lifting in the Briar neighborhood. So it's a very short-lived tornado, but it did cause a lot of damage. That's a correction on there. It wasn't June 3rd. I was looking at that and I said, this is June 3rd. It was August 5th of 1956. So now we're going to talk about Trumbull County, the tornado history. Since 1950, 23 tornadoes, 10 fatalities, 270 injuries, and 570, almost $500 million worth of damage. Just talking to Gary, our MIC here, he was talking about that storm occurred on his day of graduation. You guys can do the math, I guess. That was over, that was 85, 37, over 30 years ago. 10 fatalities, 250 that were injured. That's this storm here that moved across from Portage and actually did not lift until it went into Pennsylvania there at F5. Our only F5 tornado for our forecast area. We have a lot of F4s that occurred, but that's our only F5. And this was in a family outbreak that occurred back on May 31st, 1985. Not only had an F5 across Newton Falls and Niles, a lot of damage there. This is a generational storm where a lot of people remember that storm, and they're going to remember that storm for the rest of their life. But you had F4 tornadoes across southern Crawford County, another one in Erie, F4, F3 in central part of Crawford County. Mahoning didn't have anything, have an F2 that went to an F3 at Campbellaniana that moved into Pennsylvania. Geez, Trumbull had an F3 that was actually in the northern part. Definitely, this was a family of storms that occurred. Very dangerous situation. So I hope, just looking back at these storms, very dangerous situation. That was the day Gary said that, it was probably the most humid he has ever experienced up here in Northern Ohio on that day before graduation. We're going to take a 10-minute break for you guys to kind of stretch your legs if you want to go ahead and use the restroom. And I will be back. Let's take a 5-minute break here. I will be back at 7:25. You can drop questions in here. We'll try to answer those questions. I'm kind of a one-person deal here, so I'm going to stretch it out just to see if there are any questions. If you have any questions about what we've covered so far. If you were on the online last year, there's some changes there, but not too much. But definitely the second half, you're going to look at some new storms that occurred for October 21st of last year and how that fits in as far as reporting. We're going to talk about reporting as well. So I'm going to go ahead and mute myself and we'll come back. Let's say let's do 7:28. Okay, I have 7:26 before we get started. I know some people are probably having a return, but I was looking, as we tried to go to each county in the area, and I'm really, I'm forcing myself to look at each individual county and tornadoes and really getting to know the community. I try to personalize these sky warns with the history. And one thing that struck me back in December of 2021, when we had the long track tornado that occurred in Kentucky, it was very sobering feeling when we issued a warning and that many people perished. Um, Undoubtedly, the warning did save lives, but a lot of times, this type of situation with a violent tornado, it will um, it will yield a damage that's for an area that's unrecognizable. Um, I for this area, the average is 6 tornadoes, but we've had violent tornadoes in our history. That the one in Trumbull definitely in 1985 was a strong one and had a track that was over 30 miles. I look back at one of the storms, one of the long track tornadoes that occurred back in 1953 in June. And the one thing that I noticed, it was the first time that our office issued a warning, a tornado warning in 1953. This is before network radars were in place. We probably had a radar, but it wasn't a network radar. It's before no other radio. It was before the civil defense sirens. The only thing we had was the wire to get the information to the TV stations and radio stations. This was a long track tornado, Ohio's longest track tornado of 118 miles. You think about the technology that was back then, and these warnings went out. If you want to learn more about this, you can kind of Google long track tornadoes, or I think it's June 8th, 1953 tornadoes. It was in a family of tornadoes. So when I looked at it, me being a weather weenie, looking at all the outbreaks and stuff like that, it was in a family of tornadoes that killed a lot of people in the Flint, Michigan area, and it extended all the way across to Massachusetts. So it was and I did not look, I didn't recognize, and then when I looked at the long track tornado for Kentucky, that's when I said, what was the longest track for Ohio? That was the longest track, 118 miles, and that was significant because we issued our first tornado warning off of that one. If you look it up, I think Case Western has a documentary on it. It actually shows the ending of the tornado. Someone actually had footage of it roping out, and so that was very interesting. I think I talked long enough. I think we're at 7:29, so I better get started so we can get this done by 8 o'clock and we can actually answer some of you guys' questions. I know you guys are out there, so thank you for staying with us. But I'll go ahead and start. We're going to go ahead and talk about ominous clouds, ID, and reporting. What does it mean, how, and when to report to the National Weather Service in Cleveland? We're going to talk about tornadoes and funnel clouds, wall clouds, chef clouds, and roll clouds. Also scud, scary looking cloud, Q-fractus. Those are a lot of times we get false reports because of them, because just a snapshot, they think it's a tornado of a smokestack that you've been living by for the last 20 or 30 years. So now it's a tornado. Yeah, that happens. We get reports like that. So we're going to talk about that. Everything you got to remember is based off of context. Definitely be patient to look for the rotation. Is the rotation touching the ground? Is there debris observed? And for wall clouds, is it sloping towards or away from rain? So we're going to talk about roll cloud, and the good definition is a horizontal shelf cloud on the leading edge of a thunderstorm. Those are the kind of situation where you see it's kind of moving in. Maybe you didn't want, the storm kind of snuck up on you. Sometimes that happens. And then you get that cool brush gust of air, that comes in, it's cooler too. The rain falls and possibly hail is associated with it. And so that's that gust front, that flushing out of that cold, dense air coming out. So you got the updraft that's going up on the right-hand side, warm, moist air moving in. Downdraft is coming from the upper parts of the atmosphere that's flushing out. It's moving, and the leading edge, and it may be showing that roll cloud, that gust that occurs. Could get a gustnado that's on there, but a lot of times it's just a gust of air. You may get a rolling that could occur. And when you're looking at this on a radar, definitely radar is where the man figure is, and then you have the squall line of storms that extend. It could extend from Toledo all the way down to Indianapolis as it moves across, and you know we get pretty long squall lines across here, especially late spring and early summertime. So we're going to talk about where the roll cloud is located as far as a supercell or a thunderstorm. The roll cloud or chef cloud is going to be located near where the rain, most of the rain. If we're looking at a supercell, which this is, we're looking at a cumulonimbus cloud, and actually where the updraft is occurring near the spine of the storm. But the downdraft where the rain is occurring, and definitely that's where new storms could developing, but also where you get that roll cloud or chef cloud feature that could occur on the lower right hand side. So in a situation, you get the cold, dense air, downdraft that's coming in, gives you that cool air, 20-degree drop, but that warm, moist air is moving up and over, and you get this roll cloud or roll cloud feature that could develop. Kind of give that horizontal rotation sometimes that's occurring. Looks very ominous. Looks very dangerous. Do you report a chef cloud or a roll cloud? No. But I want you to be able to distinguish the difference between a chef cloud or roll cloud and a wall cloud. Here's another situation here. Sometimes the interaction where that cold, dense air is coming down, warm, moist air is rising above. You get that horizontal rotation that's occurring. Here's a situation where you have a cloud that's detached, roll cloud that's detached from the parent thunderstorm. Could be a situation where the thunderstorm has finally just collapsed completely, but that roll cloud's not going to go anywhere. It's just going to continue to migrate away, and it becomes detached from the storm. A lot of times when this happens, you don't get the cool air. You just get the effects of the roll cloud coming in. You may get some rain. What's happening? The air is modified somewhat. You're not getting the source region of the upper parts of that storm coming down. So that's why, if you have this situation where it's detached, you're not going to get that cool air that you normally get. You're not going to get a lot of wind. The winds may not be as strong as it was before. Let's just say that. And the hail, if there was some hail, it's on the ground for the most part. So identifying a chef cloud, the hint is slanted away from the storm. Here's another hint. If you're taking a picture of possibly a chef cloud, and you're looking at it and it fills your viewer up, what I mean is your cell phone viewer, you can't get it in there, you're panning to get the whole storm, or to get the whole chef cloud, or to get the whole cloud, then it's probably a chef cloud. It does slant away from the rain, so you see the rain to the right, you see the slant that's away from the rain. Here's another situation, you see the rain to the center and to the right, you see the slanting away from the rain. Here's another situation. This looks like a big spaceship here. So this is somewhat subjective here. There may be some slanting away. I can't really definitively say yes or no. Rain shaft is in the middle, maybe to the right. There's some slanting away, but it's subjective a little bit. Is it big? Yes, it's very big. Here's a situation where your vantage point doesn't give you a true idea of what's going on here, and so you need to be careful about this situation. You may not be able to identify this one here. Here's a situation where the chef cloud looks like it's touching the ground, slanting away from the rain that's to the left. So behind this shed or building here, you can see it look like it's touching the ground, slanting away. Do I need to report a chef cloud to the National Weather Service? No, but it's important for you to know how to ID it. And the reason why I say it may fill up your viewer is because the wall cloud is very small unless the wall cloud is up on you. So we're going to talk about the wall cloud must be rotating. So you have to be patient in this situation when you're looking at it. It's a much smaller feature than the shelf cloud or roll cloud, but it is going to be rotating. So you have to be patient. Give it 10 seconds, 15 seconds to know what you're looking at. This is where most of the violent tornadoes occur, or tornado or funnel cloud is going to develop. You have right along that wall cloud, above that wall cloud, that's where the updraft is going into the spine of the storm. The downdraft is going to occur to the right of the storm if you're at that vantage point, and then you have that collapsing of rain that's coming out, not only spreading out away from the wall cloud, but also a little bit towards it. You see that slant that's actually towards the rain? That's what you're looking for. Circulation of the supercell, it does rotate. The whole spine is rotating. The whole storm is rotating. So this is what we're looking at here, counterclockwise flow. If you actually looked at some advance, we're looking at a kind of a weak echo region right here where that green circle is. Definitely looking at rear flank downdraft. And you know what? I can draw in here rather than talk about it to make it clear. And that's what I'm going to do. So right here, that's in black. That's where your updraft is occurring. That's possibly where let me get a little bit here. Possibly where you're right here, updraft is occurring, and possibly where, and I've really messed this up drawing this, and let's clear this. Erase all drawings. Right there. So that's possibly where the tornado, or where the wall cloud is going to exist. The rain's on the backside here, where you hail and rain. You could have a situation where the outflow boundary is occurring, and maybe a little bit further out here. So it's moving in this direction. Maybe your shelf cloud is here, and your wall cloud is here. This is your rear flank downdraft, RFD. There's flow coming here as well. So not only you have flow here, this is where your hail is going to be located, right here. One thing I will say, if you have a vantage point that you're right here viewing this storm, you're probably going to see it as the picture there at the bottom. You're going to see the wall, you're going to see the wall cloud in front of you. You may not see a lot of structures because of the moisture, but if you're looking from this vantage point looking up or looking north, you may see a hue of green because of the hail that exists. Let's go ahead and erase that. Get back to my clicker. And I need to erase that before I get myself in trouble. So wall clouds formation, rotating, lowering from the thunderstorm updraft. It's going to slant towards the rain. It often preceded by a funnel cloud and a tornado, and indicates strong updraft as well. So here's a situation where you have a wall cloud, the rain shaft is to the right, but you also have that slant that's going towards the rain. This wall cloud is lowering. Give it time. You want to be able to view what you're looking at to see if that wall cloud is rotating. Downdraft occurring there. Updraft is going up into the wall cloud and up into the shelf of the storm, the actual spine of the storm. This is a situation where the rain shaft is to the left. The slant is going towards the left. Rain is coming down. Updraft is going up. If this was a movie, you could see the rotation of that wall cloud. Here's a situation here. This is where it becomes somewhat subjective because you can't really tell if the rain is to the right or to the left on the shelf cloud side. You can see the wall cloud, rain is to the right. There's some slanting to the rain shaft. And so you can see that the whole storm, if it was a movie, you could see that bottom portion rotating very slowly. here's the clue of a hint that I can give you. The chef cloud is going to be much larger than the wall cloud. If the wall cloud, wall cloud's going to be much smaller feature. It's going to be somewhat a slow rotation that's occurring. So you got to be patient with this one, especially if you're viewing it from a safe location. If you can, and if it is safe, snap a picture or take a video and send it to us, and we'll tell you different ways to do that. So tornadoes and funnel clouds. Tornado is in contact with the ground, violent rotating column of air. Not always visible, but it is vertical. Funnel clouds, not in contact with the ground. And a tornado cloud, not always visible. And, we say sometimes out west is not visible, but we had a storm in Stark County last October. They showed it on the high school video, and there was no column of air. There was no condensation occurring with that tornado that moved across Jackson Township in Stark County. Here's a situation where you have if it's a tornado or funnel clouds. It's one of the hints you're gonna see is the cloud edges are going to be very smooth. You have that smooth rotation. If you're there and you're actually watching it, you'll see the rotation as well. But snapshots, we're looking for that smooth rotation that occurs. So I want you guys to get ready to actually, I don't know if you have the chat capability. You may have the question capability. If you can drop the question here, we're going to go through some scenarios of what you can do. So I'm going to go through a couple of other ones here. This is a kind of a tornado, possibly a funnel cloud that's roping out at the end of its life. Rapidly rotating cloud edges, looks fairly smooth. So I'm going to talk about harmless scud, scary looking cloud. Q fractus is the scientific word for it. They do not rotate. Give it time. Look at it. It's very raggedy. It's not smooth like a rotating cloud, but they are responsible for many of our false tornadoes, wall clouds, and funnel clouds reports. This is kind of an old saying because I think for the most part, people take videos, but we still get reports. Last year, we got a report of a smokestack, and sure enough, it was not real. But a video of a 5-second video would have solved that in no time. So this is what a scud looks like. There's a lot of clouds. There's no puffiness to it. There's all, just debris looking, raggedy looking. And so sometimes, they see this, the cloud sometimes looks out of place, and we'll get reports that, well, there's something going on. Here's a smokestack. I'm not sure, just looking at it, it's very raggedy. It's not rotation. If you have some questions about it, be patient, look at it. You'll know if it's a rotating. That looks like probably some kind of smokestack that's in the distance. Here's another situation. I don't know about this situation. It could be something that may have been a rotation and kind of dissipated. That could have happened. But now I'm looking at it still here. Looks very ragged. It's not smooth. It doesn't look like something that's present. That's a tornado. Looks like a scud. So we're going to go and name that cloud so you guys can actually, I know I don't have the chat feature on your end, but definitely in the questions section, we're going to look at this and we're going to see, is it rapidly rotating along a vertical axis? Is it smooth or ragged? So you can drop your response in there as a question. I know the chat feature is not working, but is it smooth or ragged? I don't know. I'm looking at it here. Do I have any responses out there? Let's see. I'm not getting any questions here, so. Okay, so we're gonna go ahead and, yeah, that looks smooth. You tell right here on the smooth right there, yeah, maybe. Is it touching the ground? No, Probably not. Let's go ahead and erase my drawing here. Probably a funnel cloud. Here's another situation. Is it sloped towards or away from the rain? When the rain is to the left, looks like it's kind of up in the air a little bit, maybe. Yeah, sloped away from the rain. So that's probably a chef cloud. Here's another situation we're kind of looking, looks kind of dangerous and ominous. I don't know. Got a rain shaft to the right. Be patient. Look at it. Is it raggedy or is it smooth? Looks raggedy to me. Is the debris touching the ground? I don't see any. So this is probably scud. Here's another situation where it's sloped towards or away from the, I don't know. This is definitely out west. The base is about 65, maybe 7,000 feet. It's not like it is in Ohio and Pennsylvania where it's around 3,000 feet. So there may be some cues there. I see some rain to the right, and rain shaft is somewhat removed. This is what we call a low precipitation, a LP type thunderstorm that happens a lot out there. We don't get that much out here in Ohio, but definitely that happens there. I don't know if it's sloped away. So that's kind of puzzling. I can be patient and look to see if it's rotating. I'm going to go out on a limb and say it's a wall cloud. So we got Uncle Bob there. Uncle Bob is back another year. We can maybe replace Uncle Bob with Uncle Zach. Is it sloped towards or away from the rain? You know, the rain may be to the left behind Uncle Bob. There's some slanting towards it. Uncle Bob needs to be patient and look at that to see if the wall, if it's rotating. So it looks like it's sloped towards the rain and look like it's a wall cloud. So here's a situation where we have we have maybe something developing here. Looks like it may be debris that's developing there. I can see it a little bit right here. I don't see any column though. Is it rapidly rotating on the axis? I don't know. It's so, so much moisture and haze. I can't really tell, but you got debris on the ground. There's circulation at the surface. There's interaction with the ground. That's probably a tornado. So now we're going to talk about safety and preparedness. And this is, I pushed, if you were here last year, I pushed this graphic to fit what we're going to talk about as far as how systems, how we actually tried to forecast and how it's supposed to be neat. For the hazardous weather outlook, we're talking to the spotters, we're talking to the emergency managers in that product. We're getting information from the Storm Prediction Center. And in this stage, we're talking about maybe outlook. We're talking about maybe day 3, day 5, day 6. We may be following a system that's moving across the Great Lakes by day 5, and it may cause, the front maybe sweeping across Ohio and Pennsylvania. There may be a threat of severe weather in day 4, day 5. That could happen. Once you get a little bit closer on the day of, if conditions are still there, the ingredients are there, but they haven't come together yet, we get into a watch stage. The Storm Prediction Center will issue a severe thunderstorm watch or tornado watch, depending on the parameters as far as in the atmosphere. We may issue a flash flood watch, depending on if the moisture is there for a lot of heavy rain. Now we're getting into the warning stage. Coming from our office, severe thunderstorm warnings, tornado warnings, and flash flood warnings. This is the time to seek shelter. And it's a time, once we get narrowed down to the point, time to save lives. Then, actually, when we go out and survey the area, we need to be safe when we do that. So we're going to talk about different systems that occurred. This is from last year. We have this in here from November 5th, this is from the tornado outbreak from November 5th. There's no secret. SBC actually had a day outlook on 5 talking about possible large hail and damaging winds with possible supercells occurring day 5. So that's very significant from Illinois, southern southern Michigan, Indiana, and the extreme northwest portions of Ohio. In that section, as far as our hazardous weather outlook, we were going to talk to the emergency manager. We're talking about a cold front moving eastward across the region late Sunday evening. This could trigger showers and thunderstorms. Some of these storms may be severe. But we're also talking to the emergency managers as well. So those red highlights, the red highlights and the spotters as well. So we're talking to emergency managers, talking about the flood watches. And they want to know the impacts that we're expecting today and tonight, and also out to day 7. Spotter activation will likely be needed. So that's when we're talking to you guys as far as the spotter activation, kind of perking your ears up to kind of pay attention. Here's the situation on day 1. We kind of skipped from day 4, day 5, day 1. Definitely a slight risk across a good majority of Ohio and extreme northwest Pennsylvania, and enhanced risk across west central Ohio and parts of Indiana. Look at the tornado threat, 5% chance of it occurring within a 25-mile radius of one spot. And you may not think that's very high, but that is very significant for day 1. Then we're talking about the tornado outbreak. This is the wind probability, 15% chance of it occurring within 25 miles. That's significant as well. And then they hatched out for hail a little bit further to the southwest across southern Illinois and south central Indiana. So definitely the hail threat is a little bit further to the southwest of northern Ohio. On the day of, they issued a tornado watch at 12 midday for a good chunk of the area, Indiana and northwest and north central Ohio. First, severe thunderstorm warning goes out for Wood and Lucas. Radar indicated. So this is kind of the first thing that's occurring. A lot of reports haven't come in. Some of our spotters are not in position, or it's just, you know, the initial time sometimes that's when we, you know, it's basically by radar. But then when we start getting reports, then we can kind of indicate the emergency manager or spotter indicated, spotter observed a tornado or a funnel cloud or hail size or something like that. We issued our first tornado warning for Erie County and north central Ohio. That was radar indicated. Then we started getting reports. This came in from a 911 call center. That may have came in from a spotter or a public that called in the 911 about a tornado that hit a bedroom that was destroyed near the Sandusky, Erie County line. This is a wide view of what we're looking at. It does look like a mess of storms as far as being scattered and numerous in nature from the western portion of Erie, Lake Erie, all the way back to St. Louis. Look like just a plethora of storms that's moving across. Definitely the threat is there for severe weather. Here's the outbreak of what occurred. Definitely had 3 strong tornadoes, EF2s, and 2 of them were actually in Ashland and Huron County. So just you know, quite a few, especially across north central Ohio. We had 1 in Andover and Ashtabula, and 1 in Erie, northwest Pennsylvania. 14 tornadoes occurred that day. So that was forecast 5 days out. You know, the area was a little bit further to the west, but we did shift over time to the east across northern Ohio. But that was, you know, for something that's forecast out, we were alerted the emergency managers and the spotters. And so you think we did some things, but sometimes, you know, there's some curveballs. We have some challenges. Here's to confirm the tornado in Ashtabula, EF2, 127-mile-per-hour winds, destroyed a house off the foundation and moved it off the foundation, a lot of trees down. Here's one in Sandusky, EF1 damage. Definitely a situation where the house is just really ransacked. I mean, geez. These are supposed to be weak tornadoes, or strong to weak tornadoes, still causing a lot of damage. And people could die in this situation. Luckily, no one died in these tornadoes. rafters of a store, a kind of not a store, but a storage bin with, just torn up. EF2 damage, EF1 damage to the right. There were some challenges. These storms were moving 40 to 60 miles per hour. That's kind of difficult for a spotter to give you help on that situation. But we're doing the best we can. But with the situation and environment, they're moving 40 to 60 miles per hour. Tornadoes were occurring. They were obscured by rain. That can be a situation where the spotters cannot see anything. And that's unfortunate, but that does happen. We went from daylight to dark in the middle of the event. That's a situation where we, not only commuting, but people are going home. They're in their routine. We had a watch box out, but still, people are still doing their routine, so that could be kind of difficult. Radar signatures and indicating rotation and tornadoes were short-lived. They were one scan, they were there, and they were gone the next. These tornadoes did not have long tracks. And the reports came in kind of, they were delayed. That happens sometimes. Well, we start getting reports, and then the phone was ringing off the hook. And so that, when it rains, it floods. And the idea of not getting reports and then a bunch of reports coming in, that does happen in a severe weather event. So now I'm going to talk about October 21st, actually less than 6 months ago, about 6 months ago, for a tornado outbreak that occurred last fall. SBC outlook for day 4 to 8, they were not showing a thing. And then sometimes we don't get the national outlook that's showing anything. That happens sometimes. But for this event, they wasn't showing anything. So this is actually 4 days out on the 18th for an event that occurred on the 21st. We're talking to the spotters. Normally, day 4, we're not going to say anything like spotter activation needed. Sometimes most of the time, it's going to be within 48 hours or the day of the event. But the message to the emergency managers: no hazardous weather expected at this time. Day 3, now we're getting to a little bit closer. We had a marginal risk for extreme northeast Ohio and western Pennsylvania. There's a 5% chance of damaging winds, the probability. Nothing for tornadoes. It's day 3. Day 2, not much change. Looks identical to day 3, so not much change there. And the tornado threat was not present. This is from the national centers. But we were also saying that here locally. The day of, that's Thursday morning, the national centers expanded the threat of marginal risk for severe storms from Erie or from the western portions of New York all the way down to Alabama. They also extended the wind probability for damaging winds all the way down to Alabama as well. That morning, we did not have a tornado threat. It wasn't until probably 10 o'clock, 11 o'clock when we started getting some new model data from the soundings and some of the balloons at 6 a.m. Then we started to indicate something, and we start messaging that to the emergency managers that may be a threat of tornadoes. And the reason we struggle with indicating possible tornadoes in the fall because the instability is not in place a lot of time, and that's what we struggle with. It's a very dynamic system, had a lot of shear, but the instability, that's one of the ingredients you need for a thunderstorm, was not present leading up to the event. But it became present when we looked at the models by midday, knowing that we knew something was going to happen, and we started messaging that to the emergency managers with briefings and stuff like that. This is like a surface map, surface low over Lake Michigan, kind of approaching us, showing a front from Michigan all the way down to Indiana to the Arklatex region. We're definitely kind of in that warm sector because the warm front has moved north of the Great Lakes area into Canada. So we're in that warm sector area, and I can draw on here where that is, where that warm sector is when, just talking about it, right in this area here. That's where that warm air is coming in from the Gulf. Our thinking was that warm air wasn't going to get as far north as it did. This is the upper air at 500 millibars. This is about 18 to 20,000 feet. We noticed that day, that morning, we noticed a little kink, a little trough that's approaching us that was stronger than we anticipated. That was a key. This little key here. That's a trough that's approaching. That's when we know, uh-oh, something's going to happen. Sometimes it happens that way, and especially in the fall, because a lot of times we are struggling with the instability. Is it going to be in place? Is it not going to be in place? That's what we're struggling with. This is the event as it occurred. Broken line of storms that developed, moving east. Those little red polygons are tornado warnings. As it moves across, a lot of the northeast counties were affected by the tornado, especially Trumbull County, Portage, Stark. A lot of counties were affected by the tornadoes. We had 8 tornadoes in about a 2 hour and 15 minute span from 4:30 to 6:30. We took a win because our shift changed at 4 and the people stayed behind for the day shift. So we had enough people there. You got to think, this is also during a COVID situation, so we didn't have a lot of staffing in, but the core meteorologists were here, so they were able to work this event and pivot very fast. We were able to get messages out to the emergency managers, and the media jumped on it as well. So we were communicating not only with the media, but we're communicating with the emergency managers. So we did the surveys the day after, and we did surveys almost a week after that, verifying some of those tornadoes as well. Note that's occurred, but there was a lot of damage to homes and some buildings and baseball fields. So how can I be the best help? How can a spotter best help the warning forecaster? As soon as it's safe to do so, report it as quickly as possible. Never assume that we know what's going on. A lot of times we don't know. We have people here kind of data mining, looking at all social media. We're able to look at the different telecasts from different metro areas, but again, sometimes they go undetected or unreported. Know how to get the information and remain weather aware. You know the websites. You know how to get the information as far as knowing the outlooks and where to get that information, when you're going to be activated. For the reports other than tornadoes or significant damage, consider sending the reports in digitally through the web page and social media. We're going to go over that, and through email. And you want to keep your reports concise and descriptive. Tell time, event, and location. First of all, at least for reporting, you want to report anytime there's hail, penny size or larger, 50-mile-per-hour winds or greater, wind damage and lightning damage, flooding, tornado, funnel clouds, and wall clouds. Remember, I didn't say roll clouds or shelf clouds. We're reporting hail, time, event, and location. You want to relate it to a coin. You do not want to relate it to a marble, because we know Texas marbles are bigger than other marbles. We don't know. You do want to keep it to the coin size, or if it's to a golf ball or baseball, softball size. For damage or wind gusts, approximate time will do. We can actually detect and actually look at radar to kind of get a time frame of when it occurred, or get an exact time. You want to know what is the damage and why. If known, the width and the falling of the branches, we can kind of tell what kind of wind occurred with the branches falling off. Estimate the wind and wind speeds if you can't do that, or if you have a Davis system. I know some people have Davis system. They have that detection on there. We do data mining. We look at all the networks here. We look, we look at all the networks to kind of find out. But a lot of times, if you have that instrument that's not on a network, yeah, just give us the report and location. You want to estimate those wind speeds by large branches, 25 to 31, 32 to 38, whole tree moving. It gives you an idea of estimating the wind speeds. As far as tornadoes and funnel cloud, time, event, location. Remember those: wall clouds, funnel clouds, and tornadoes. Flooding, time, event, location, the water depth as possible. Is this flooding typical for this area? If it's nuisance flooding, a lot of times we get emergency managers, they'll tell us, yeah, this is kind of typical for this area. But if the bridges are washed out, yeah, report that. Road closures, report that. Sometimes we get the reports from the emergency managers, but don't assume that we know what they're doing, because a lot of times they're busy. They're busy doing a lot of stuff, but if you see a road closure, report that to us. And location, what part of the county. Lightning, we do not issue severe thunderstorm warning, but if there's any kind of damage, yes, report that to us. Different ways of reporting it to us, either by cell phone, PC. There's also MPing, and I'll talk about that crowdsourcing for weather reports. Excuse me. Facebook, Twitter, and Instagram, and also CocoRoss, and we'll talk about that a little bit in the next slide. If you have a print screen feature, go ahead and print screen this. These are the ways to report weather reports to our area. The 1-800 number is a current number. It's for official reports. It is not for fishing reports. I said official reports, not for fishing reports. It's not getting a forecast. It's not getting a rainbow. I see a rainbow. It's for severe weather reports. Facebook, you go to our Facebook page. You can interact with us through Facebook. Twitter, if you use the hashtag SkyWarnCLE with the picture, with the time, event, location, information, if we like your tweet, that means we have your information on there. We're going to have the amateur radios in tomorrow to actually hook up everything, and hopefully we can have them in this summer. If it's online, I'll show you how to do that online, what it looks like. It's actually on the front of our page, and you can get to the online reports with the same area where you saw the SkyWarn information. You get there, and I'll show you that. If you want to email it, it's not the best for time-sensitive reports, but again, if you want to email us, it's stormcle@noaa.gov. In the website, for our website, as far as reporting, you go to Storm Reports and you'll see this kind of interface, very intuitive. You can actually go in there and actually pick out your location and also other information as far as what type of hail or what type of weather phenomenon that occurred. And that goes directly to our our StormCLE account. So we'll get the email there. This is our amateur radio districts. National Weather Service, definitely. I'm not sure if this is an updated one here. I know some people in the field have told us, hey, you need to update this one. If you have a new district map, yes, please send it to us. We'll get that information and we'll upgrade it. CocoRoss, we talked about this. It's kind of a community collaborative rain and hail and snow network. It's kind of a grassroots, nonprofit, community-based, high density. We actually use it for the Snowfall, and it works very well up here, especially in the snow belt. If you're interested in that, print screen this, and you can actually report, get some more information from Zachary Zefkovic. He will get that information to you as far as getting into the network and signing up for CocoRoss. MPing is meteorological phenomena identification near the ground. It's not only for severe weather, it's for other features. It's actually a conjunction of University of Oklahoma and NOAA. It's somewhat like an app, but the University of Oklahoma runs the app. It's a network of stuff. It's actually pretty good, especially in those days where we kind of rain, snow, maybe rain, freezing rain. A lot of people are reporting what they're reporting, across this app, and it lights up. You can see who's reporting rain, who's reporting snow grains. who's reporting dense fog. It's a very useful tool not only for severe weather reports, but other phenomena that occur as well. In summary, never assume we know what happened. We want to make sure that you guys are safe. We're training you guys to be spotters, not chasers. Time, event, location is however you interact with us or your emergency manager or 911, you want to give the time, event, location. That information will eventually get to us, but you have those ways of getting in contact with us. Thank you for helping us protect life and property across northern Ohio and northwest Pennsylvania. That is all I have for today. I don't see any questions in the bin. I will stay on. I think it's 8:30. If you want to print the screen or print screen and copy that, if you have any questions, you can email me and I'll try to get that information or try to give you more information on there. And I'll try to get that information on there as far as answering the questions there. As far as the certificates, you can actually go online in the same area where you registered for this class, for the Skywarn class, you can get your certificate. As far as the cards, that is something if you could actually go to Skywarn card, and I believe it's Skywarn 2022 as a password. That's going to be out of the Wilmington site. In person, we're going to try to do some of these classes in person, especially for Trumbull, Mahoney, and Portage. Hopefully in the fall, if we can get out there, we're going to have plenty of cards there to give. I know some of these cards, some of these people, some of you guys have had these cards for quite a long time. We have the cards here right in front of the camera. I need to put it in. And it has a spotter number. We don't use the spotter number anymore, but it has the same information. These are nice stock cards, and so we have quite a few. If you want the stock cards, I know printing it at home on paper, it's tethered a little bit. So if you want to wait, to be in person, I'm going to talk to, I'm going to talk to Brett Lee and some of the others, Andy, some of the emergency managers, to see if we can get in person. You can get those cards to you guys. I appreciate your time and thank you for attending the Skywarn online. I'm not sure if there's going to be another one. Our schedule is pretty tight. We got 4 events next week. We're going to be going out in the field, and 4 events the week after that. And then we have four events, I think 4 events for the first week of May. And that during that time, we're going to start getting some people on leave, and weather may be affecting us in the next week or two. So that's something we're going to have to watch. But if any event, those events are canceled, we'll move them to the fall schedule. That is all I have. Thank you very much for being on. I don't see any questions. You're not getting any comments. No, I'm not getting your comments. Hold on for a second. I see one from Troy Jarvis. Let me take a look and I'll see if I can enlarge my questions. Let me hide my face here. And I'll see if I can answer some of these questions. I'm going to try my best to see if I can maneuver this. Let's do a tearaway. Let's see, most of the questions I see yes. Oh, here are some more questions. I'll answer some of those questions that come up, and yeah, I see a lot of questions. I see people responding. I think my tab was just scrunched down. Portage County has a free app to receive severe weather alerts. That's according to Brett Lee. So if you're out in Portage County, you can actually get that information. I assume that's the website. And I'm going back a little bit. This is at 6:30. I apologize. I'm the one person here, so I can't walk and chew gum. I apologize. Let's see. I've looked for somewhere else. See if any more questions. We looked out. Oh, okay, this is Garrettville. What exactly is instability? That's the moisture and warm air, and if it's lifted, it would actually, it's if it's lifted, it gives you an opportunity for the atmosphere to work with. It's the kind of the fuel for a thunderstorm. If you don't have instability, that one tool, as far as the fuel for thunderstorms or the unstable air, you know it when you feel it, especially in the summertime. You wake up in the morning, it feels muggy and it feels moist and it's warm. That's unstable air. If that unstable air is lifted either by a trigger or a front or just the surface being heated, then it can become these pillowy clouds, towering cumulus, and possibly a thunderstorm. And we got a question: what is the criteria of heavy rain? And that's also dependent on the location. If it's a metro area, urban area where there's a lot of runoff, 1 inch of rain may cause a lot of damage, a lot of runoff that could occur. If it's in an open area that's very drainage, you have a lot of drainage that can occur. Maybe it's close to the lake or close to a river that can handle a lot of drainage, then 1 inch may not occur. So it really depends on the area there. What is the phone number to report the number? So somebody asks, if you want to report, that number is 1-800-262-9683. I'll repeat that number, 1-800-262-9683. That's for severe weather reports. What makes it possible for a tornado without the cone? Well, that happens a lot of times. You get the circulation, but you may not have enough moisture in the air to cause that condensation to develop. It's actually the cloud condensation that's occurring. So there may not be enough cooling in that circulation to get that cloud to develop where you don't get the full cone that develops down to the ground. So that's why you're looking for the debris that's on the ground. What opportunities? Let's see, we got one question here. What's the phone number to report? I think I can make this wider. Let's see. What opportunities are there to become a storm chaser? I'm here to train spotters. I don't train chasers. I know there are chasers out there, and believe it or not, I do follow them on Twitter because they get pictures and but I can't tell them not to chase storms. I'm trying to tell, as an agency, as a federal agency, I'm trying to keep people safe and for them to remain as spotters in their safe person and not put themselves in danger. And I don't want to put anybody in danger in that way. What tornado intrigued you the most? What tornado intrigued you? I was in college back in '92. We had 2 F4 tornadoes in Mississippi, and I would go home to Florida, and the tracks that occurred, there were 2 tracks that occurred, and it looked just like a lawnmower across the pine trees. These pine trees were 120 to 150 feet tall, and then all of a sudden you saw this feature where this F4 just mowed them down. In some instances, there was just maybe 10 feet off the ground. That existed. It occurred in my sophomore year. It existed all the way to my senior year. That was almost 30 years ago. I haven't been in that area in some time to see if that exists still, but that's really, that was the first time I actually saw damage or the path of a tornado. What sort of info does National Weather send to local media? Well, it's not necessarily sending to local media. They have, we have WeatherWire that sends information, that sends alerts out to the emergency managers and Ohio EMA, and also if a TV station supplies to it. But there's all kinds of secondary companies that package our warnings, our watches, our maps and stuff, and it puts it in a way that's, I would say, that's presentable some of our data is raw. You saw that surface map, it had lines, isobars, and everyone there. So they have a better way of actually presenting that information, and they're presenting it to a larger group of people, and so it looks a lot nicer than our graphics do. We try to do as best we can here, but again, we try to do the best we can as far as the graphics, but we want to make sure people understand it. I see a question here. Where do you get the certificate? That certificate, you can get that information. I can actually show that here. And let's get out of here and go to our website. So if you want to get our certificate, go to local, Skywarn Spotter, and kind of give me training too. Just hope it's not hidden. Skywarn class, and get your spotter certificate right here. Type in your name and the class you went to. And so this is going to be an online class here, and I think it's here. Where did it go? I don't see online. Let's see. You're probably, for Mahoning and Portage, you're going to go ahead and select these two. I don't see the online feature on here. And I'm glad I went through here. I had that a little bit later, but if you want to go ahead and select Mahoning and Portage, you can select those and then put your name, and then you'll create the graphic for you. Okay, next question. Where do I get the certificate? I already answered that question. Will there be an advance? We've been kicking this around, and if you probably already know, some of the National Weather Service office are trying to do away with some of the Skywarn classes and actually just do it as the emergency manager or the group's request rather than a full schedule. The advance, this is something I'm going to bring up with our WC, our Warning Coordination Meteorologist conference as far as the advance. My neighbors, I guess to the south, they do offer it. My neighbor to the west do not offer it, and because it's such a small group that you're catering to, I know there's been a lot of we get a request every time we have it online, so it's something I'm going to look into. We have not created an advanced course as of yet, but it's something we're going to look into, and I'm not sure if that's going to be something we're going to be shifting out of or not. So I'm going to have to get back with you on that question. And that was from, well, that person has left. So what sort of info does and sent to the media? Okay, I think I'm getting behind here. I can hear and see the screen. Okay, that's late. Okay. I think that's about it. That's all the questions. I appreciate your time. I think we're kind of losing everybody here. Again, I appreciate you guys sticking it out with me for 2 hours or 2.5 hours. And if you have any questions, we're going to try to be in person for Trumbull, Mahoning, and Portage County in the fall. And I have some snow information in there as well. Remember, severe weather occurs any time of year. Tornadoes occur any time of year. Severe thunderstorms occur any time of year. Minnesota had their first tornado that touched down in the month of December. So things cannot be ruled out. I mean, it can occur. That is all I have. That's closing it out. I'll leave my information up here so you guys can see that, and I will close out and leave it up for about I'll leave it up for about 5 minutes and close out at the bottom of the hour at 8:30. Thank you very much.